Alright guys, back again with another Bronco video. So today we've had some people ask and I'm going to be going over motor mounts. So the old ones I used, if you look at my old video, they were not very good, kind of just a piece of plate steel with an adapter to a single bolt to the motor mounts that Ford used originally. But this time I went through and actually made some nice rigid motor mounts. I'm doing the whole thing rigid. Just, personal preference for me. And in this video, I did make it, the plasma cutter for us is just a nice tool, but any regular person should be able to do this, if you got a cutoff wheel and some cardboard for stencils. So I will have to dub over this video. It was a pretty loud day in the shop, but I still wanted to shoot it while I was working on it. So let's take a look at it. All right, so first thing I did here is I'm just showing you guys kind of where the motor mounts are going to go. Sorry for my chair squeaking. I have this jig here that I set up, and where those plates are is actually exactly where the mounting holes are on the motor. So I showed you guys hopefully in the last one that my hole setup is all level here. So the frame is level, sideways and lengthwise, which you want makes measuring super easy. And also where my motor mount is sits level, so that way my motor's not sitting, leaning left or leaning right. And also when I have it here to there, I did add 3 degrees actually down in the back for the motor. So this one might look just a little bit off there, but I had my angle finder and it is exactly 3 degrees down for the transmission, which just gives me a little bit better angle for my rear drive line and should help me in the end. This is the old motor mount. You can see where that single hole was and where it was originally. There was a plate in there, but that's how I used it for the old one. There was just a single bolt going up to mount to the 4 holes on the LS motor. Here you can see a line where I actually moved the motor mounts forward an inch. There was some unused space in the front when it was in there before, and the longer I can make that rear drive shaft, it is better in my opinion for me, because before I think it was only 29 inches or something like that. It was a very short rear drive shaft and kind of had some vibration. Here's the forward axle. They had some ears on there from the factory that I had to cut off and patch, and that being cast, it took me a while. I had to preheat nickel rod, completely cover it, because when I cut those off, the casting actually went and I could see the axle tube. But here it's getting pretty close to be able to set up for my trusses and my link points. So still got to do some disassembly and stuff there, but hopefully we'll get to this in another video before too long, just kind of going over it for you guys. The truss will go on top of there and that'll all be shelled apart, so that way we can set everything up. But got those ears off, so now we can clean the whole thing up and find our actual link points. Those are getting cut off. Those are just some clamps for the brake lines, but we're going to do something a little more clean, maybe some steel braided line or something. Just going over here, yeah, you can see that all that needs taken apart and cleaned up. This is all pretty much, I don't know the last time that any of this has been, fixed up since 1979. I don't have any record, and this stuff looks pretty old. But going over here to our motor, so I'm going to kind of go over the way that I built this jig for you guys just as a reference. So I stuck these plates, you can see your 4 mounting holes there. I stuck these plates on there, and then I actually drilled holes for the first ones, but once I had those, I ran a bar down underneath the oil pan and then back up to the other side. But I actually bolted those plates to the motor first before even putting that bar down underneath there. I made it rigid with gussets, so that way it was a solid piece, and it showed on the actual outside of the motor wear. So here, I ran that plate in between so it'd get out of the way, but there was a bar coming down underneath there, and it was all welded together. So even on the bottom sides, I had to cut those welds after I put this bar in there and welded it to there, and then set it up to my jig with my height. So, a lot of process here, but I wanted to make sure that it was exactly where my bolt holes were and it was sturdy, so that way I could make this jig, set it to where I wanted to on the frame, and then I tacked it with some short beads to the frame to hold it. So now I know where the motor's at and I know where I'm going to on the frame. Now I have this empty space here to build this motor mount. And that way I know, because of this jig, that when I put and weld these mounts in, that when I set that motor in, it'll be perfect. So here, I'm going to do it the right way. I'm just measuring where these bolt holes are, finding center, X-checking, so I can actually make a nice plate instead of the last ones I made was, just a Sharpie on a piece of steel and then a drill bit. But we're going to utilize the plasma cutter now, since we have, we have the equipment for it. So here I got it over into just our 2D cam for our plasma cutter. I made a cardboard stencil almost exact of the other ones just so I had something to reference in the office. And like I said, guys, you can do this. You can do like I did the first time. You just cut out a square. I use like 1/4 inch or I used 1/4 inch plate for this, but you guys can cut this with a cutoff wheel and a drill, and you can do the exact same stuff. I love using the plasma cutter just because it's a little bit more accurate than my hand and definitely saves time. And then we can actually throw in a little bit of flare in there also. So I got, my width, my height, and I found all my centers of my holes. And our plasma cutter isn't super accurate, so I ended up not cutting holes but cutting center points. Here I am, finding my width and height for my other plate. So this, I'm going to try to cover up all those holes to where there was shock towers, motor mounts, and other stuff on there. So I'm kind of making a patch plate here, but it's actually also going to act as my motor mount plate that bolts to the frame. So I don't know if you guys seen old Broncos, but there's just a bunch going on there. So I'm trying to utilize some of those holes, but also cover up all that junk. Alright, I got them bolted in here. Like I said, you saw me just punching center points on that little deal. Like I said, our plasma cutter is pretty close, but sometimes with holes there'll be a little taper just from the plasma. So I actually stuck the correct die size in our iron worker and punched them to the right size holes. So now I'm just bolting. These plates that are bolted in are going to be a part of our motor mount. So they're bolted in to where everything is exactly where it's going to be when it's touching that jig, because that jig is our motor pretty much. So now I'm just kind of mapping out where I'm going to lay these pieces of steel, so that way I'm not getting too close to a hole to where I can't get a socket over the nut. So I want to stay just far enough away from those bolts that it makes them easy to put in, but also I want them to be as strong as possible. So I could go through SolidWorks and design these up, but I kind of want to also do this for you guys and show you that you don't need a bunch of fancy equipment to do this stuff yourself. If you're doing it this way, you will want the motor out of the vehicle and have access to where you're building your motor mounts to your frame. And then building a jig, it's not hard, guys. Just set it up to a way where you can build, tack something together that gives you an idea of, where the motor mounts go. And then from there, all that you see right there, it's just tacked to the frame. And I'm just one piece at a time marking and cutting out pieces of cardboard. And I'm also, you'll see me, I'm mocking the whole thing up. You see me taping them in. I'm not just making one piece and then moving on to the next. I'm actually setting that piece in and then I'm leaving it there. So that way when I get all these pieces cut and taped up to this jig, I'll be able to see, you know, kind of exactly how this mount will look in steel. I don't want to, you know, one piece and out, because then if you mess up another one a little bit, you amplify that by, you know, 3 plates per side. You're going to do a lot of trimming and stuff. So just tape it together, take a step back, and that way, like, if you like the way it looks, perfect, you know, transfer it into steel. But if you want to, you know, add bends or maybe flare it out or anything like that, it'll make it a lot easier in the long run. So. Really take your time with this, guys. The better those cardboard templates are, when you transfer it over to steel, the easier it's going to go together. You want nice tight gaps so it makes your welding easier. I was actually able to TIG weld this whole thing with pretty tight gaps, so you'll see me here in a bit, but I tacked it up with the MIG welder and then went over it with the TIG welder on the bench, and it fit together almost perfectly. You just take your time with these cardboard templates. All right, now I've got my plates cut. See my first one tacked in, and this is where, you know, guys, it's going to take a little bit of finagling. You know, cardboard's bendy, 1/4-inch plate steel is not. So you might have to do a little trimming, but it shouldn't be anything too major, you know. So here's the rest of them cut. I just added some holes, you know, logos. Just like I said, we're adding a little bit of flair. Nobody's really going to see it. We're going to have, you know, some decorative panels and louvers and stuff inside the engine bay when we're done, but I want it to look good. So I got my pieces cut. Now I'm going to start fitting them together. And they're just the exact same as those cardboard templates. You'll see me, like I said, sometimes you have to do a little trimming and fit up, but the more fit up you do to make those fit almost perfect before you weld the whole thing together, it's just going to make it look better, and it's going to be way smoother when you're done. All right, I got them all tacked together. I did MIG weld the insides just because I'm a baby and can't get my TIG torch in there very well. But the outside, where people might see, got nice TIG bead all the way around, make it look good, and it's much smoother and no spatter like MIG welding. You know, every welding process, you can fuse the metal, but I just think TIG welding always looks a little better, so, and it helps me practice. But there they are. You can see them all welded up. Now we pretty much just have to get them on the frame and then set the motor in. I do have to cut off this jig now. And since we have this jig and we know it's pretty much perfect, those holes in the frame, and they're just, you know, half size over bolt, there will be not very much play, but it should be enough to where if there is, you know, we do want to move the motor a little bit, there should be just enough movement to get them to fall in pretty easily. Got those cut off and ground off my welds. I think I'm going to get new hardware, but these were the factory bolts from Ford for the old motor mounts, shock towers, and everything that was on the front of this 79. So it helps me to just reuse it. They're perfect size and make sure I can get them all bolted up nicely. right, guys, I think my next video, you should see me building the training mount, because that's next, and you'll actually be able to see the motor in. It is in now, and it's sitting on a temporary training brace, but I want to make sure I show you guys that next round. So I hope you enjoyed, and hope my voice didn't drive you too crazy. So until next time.